Hello friends and welcome to a lecture on Python. Today we will learn how to use sympy. This will be an introductory lecture on sympy. So to start with, I will show you how to install sympy in Jupyter. So you do pip install sym and run it. Well, as it was already installed on my computer, therefore it says requirement already satisfied. And you may need to restart the kernel to use the updated package. So let's restart the kernel. Restart. So I can do away with this cell. So let's delete it off. And now let me import sympy. Also from sympy import star. That is, we import all the functions from sympy. And we also do import math. Now let's see what is the difference between the regular Python libraries and sympy, for mathematics at least. So let's do one thing. Let's print. Oops. What's happening? Yeah, right. Print math dot sine. That is, we want to get the value of sine 3. So this gives you, that is the math library gives you the numerical value of sine 3. Now let's do it using sympy. So we do print and run it. As you can see here, it has symbolically represented the function and it shows sine 3. It has not calculated the value, but it has symbolically represented it. So this is the difference between a regular math library and sympy. Now you may be wondering that what are the advantages of this? Yes, there are obvious advantages of symbolic computing, and this is also known as computer algebra systems. That is, sympy is also known as a computer algebra system, and it has its advantages in mathematics. And let's have a look at it, what exactly it is. So let me change the position of the mic. Okay, yeah. Let's start now. So first, let us print math dot sqrt, that is the square root of 7, and let's see, it calculates the value of square root of 7. Now let's print once again sympy dot sqrt and 7. Now what should happen? Yes, it should symbolically represent the square root of 7. So now let's start with our regular dose of sympy and how it is useful. So first we write expr, that is expression. And before that, what we do is we import the libraries for variables. So we write from sympy dot abc import x comma y comma z. Right now, these are the variables we are importing. So these variables will help us in doing symbolic calculations. So these variables are also symbols. So let's run it. It will be evident now. Let's write expr, that is expression, is equal to x plus y, and let's run and see. What do we get? We get the expression as you can see here, it is x plus y. It is only an expression. So let's further do it now. Further, let's explore it. Let's take a quadratic expression, q ad quadratic and expression. Okay, so before we get the quadratic expression, the quadratic expression will be ax square plus bx plus c. So we will have to again define further symbols. So from sympy dot abc, we import a, b, a comma b comma c as symbols, right? So we write now QAD quadratic expression as a x square plus b x plus c. And let's see the output now. So as you can see here, the output of quad EXPR, that is the quadratic expression, is ax square plus bx plus c. Now, if we have to get the roots of this equation, all we have to do in symbolic Python or sympy, and you can also call it computer algebra system, you have to write solve, and you have to write QAD EXPR comma x, that is solve the quadratic equation for x, and lo and behold, you have got the analytical expression for the roots. Now, isn't that great? Now let us say we want the value of roots of a particular equation where the values of a, b and c are supplied. So let's take an example for this. So what we do here is we write QAD quad EXPR dot subs subs, that is short for substitute, and we substitute the values of a, b and c. So we take a as 2, we also take b as 2, and we also take c as 2. And we of course assign this to another variable, that is EXPR1. And we see the output of EXPR1. So let's do it. EXPR1. So as you can see now, the equation is 2x squared plus 2x plus 2. Now, if we want to find the roots of this equation, we write solve EXPR1x. So there we have the roots of the equation in a symbolic manner. If you want to find the value of these roots, so what do? We already can see here it has I in it. I means it is imaginary. So what we do is we write complex. So first what we do is we have solved this equation. So we assign these roots to another variable, that is SOLN, and again execute this. Then we write complex zero and therefore we get the first root, that is minus 0.5 minus 0.866 whatever after that j. If we want the second root, we have to write complex and here we get the second root. So this was a brief introduction to the power of symbolic Python, that is the computer algebra system of Python. Hope you have enjoyed this lecture. Many more to come, and it's going to be a very exciting journey. I can assure you one thing, that if you follow these lectures, you will feel very motivated to pick up any mathematics, higher mathematics textbook and solve all the problems, and again start enjoying mathematics the way it should be enjoyed. So goodbye friends. Have a great time. Have a great day.